So today we're going to be doing Unit 6 quadratic expressions and equations, and this lesson specifically will be vertex form of quadratics. So let's talk about what vertex form is. This is the same thing we've been dealing with, but it's a new format. And that format is y equals a times x minus h squared plus k. So that's what we call vertex form, okay? So let's talk about what the vertex is from this format. So the vertex is known as h comma k, okay? So you can actually extract the vertex directly from the formula, okay? And what do you notice about the sign of h in the formula? What's the h? Is it?
It's squared.
It's squared. The whole thing is squared, but what's the sign? Is it negative or positive?
Negative.
It's negative, which means that when you take it out of the equation, if it's minus 4, it's going to become a positive 4, okay? But what do you think would happen if it's a plus right here? What do you think your h is going to be? Negative. It changes sign. So if you want to write a note, h changes sign, okay? Your h changes sign. Tristan. I just lent you a pencil. Let's do better. Okay. Now let's do the axis of symmetry. So we've been learning in this class that the axis of symmetry is always x equals whatever the x coordinate of your vertex is. So it's going to be x equals h, and that will always be your axis of symmetry. So remember, important things here. This is vertex form. You can identify the vertex just by pulling it out of the format, but the h always changes sign. The k does not. The axis of symmetry is x equals whatever your h value is. Everybody good so far? Okay.
Yeah.
So directions here are going to be give the axis of symmetry and vertex of the following quadratics in vertex form. Okay. So underneath it, I'll draw what vertex form looks like. Y equals a times x minus h squared plus k. So let's identify our axis of symmetry. But first, before we do that, let's do the vertex, because we usually...
Is that times k or plus k?
It's plus.
Yeah, I think it's a times k.
No. So your vertex is always h comma k. So what's your h value in this situation?
4.
4, but the 4 is going to change sign, so it's actually going to be
Negative 4.
negative 4. And what would your k value be?
4.
Negative 2. So the k value does not change sign, the h does. Everybody see that? Now, axis of symmetry is always x equals whatever the first coordinate of your vertex is, which is x, which is negative 4 in this case. So whatever the x coordinate of your vertex is going to be the axis of symmetry. Does everybody get that?
Yeah.
Okay, let's try the next one.
I hate the graphs.
Wait.
Yeah. Oh, sure. All right. So the next one. Remember standard form, I mean not standard form, vertex form of a quadratic. I will line it up underneath so you can see it. Okay. So let's find the vertex first. What is going to be the x coordinate of my vertex? It's going to be my h. What is my h in this case?
Negative
3, but the 3 has to change signs. I mean, it's negative 3, but the 3 is going to change signs, so it's going to become a positive 3. Everybody see that? This 3 changes signs. Positive 3. Okay. Now, what do you notice about k? Is there a k in our equation?
3.
No, so this would just be
0.
0. If you don't have a k, it's 0. And the axis of symmetry is always x equals the first coordinate of your vertex, which is 3. Does this make sense so far? Okay. It's really just a visual thing right now. There's not any math involved, it's just visualizing it. Are we good to move on to example 3?
Yeah, I did number 3.
You did number 3?
Yeah.
Good. Do you want to share with us what you got on number 3?
Sure.
What'd you get for the vertex?
I got 5 and 4.
Good. 5 and?
4. Oh, no, wouldn't it be 5 and 4?
It would be 5 and negative 4. The only one that changes sign is the first one. The k doesn't change sign, just the h. Does that make sense?
Oh.
So your h value changes sign, but the k does not. The k stays whatever it is. Okay.
And then the axis of symmetry is 5.
Good. X equals 5. Make sure you put the x equals there.
Yeah.
Good job. Does anyone have any questions about example 3 so far? All right. Let's move on to the next one. Okay. So, on the next one, let's think about what the vertex form looks like. A times x minus h squared plus k. Now, what do you notice we're missing in this one? Which letter do we not have?
K.
We don't have h. We have k, because k is this one right here. You see that? But we're missing the h. So what do you think the h is if we don't have one? 0. And what's the k? 3. And what would be my axis of symmetry?
0.
Good, x equals 0. So if you don't have an h, it's 0. If you don't have a k, it's 0. H always changes sign, k does not. Those are the 3 main things. Axis of symmetry is the x coordinate of your vertex. X equals the x coordinate of the vertex.
No, H wants to be
The h is the one that's going to be added or subtracted from the x inside parentheses.
okay.
See how we don't have anything?
Oh my god, now there's
Oh, wait,
four.
so you're saying so like, there's parentheses and there's an H? Is that what you're saying?
Yeah, so basically the parentheses will be like, it's going to be parentheses x something minus something. That will be your h. But if you don't have the parentheses there around the x, there's not going to be an h there. All right. So the next one wants us to graph this. So let's talk about how we go about using the table to graph this. So the middle of your table should always be your vertex. Now looking at this equation, like we just have been practicing, what's the vertex of this?
7, 2.
It's going to be -2, 7. Does everybody see why it's -2, 7?
Yeah.
H and K. Okay. I can zoom out, but I know it's tiny, so -2, 7. And your vertex is always going to be the middle of your table, okay? So put it in the middle of your table. Now, to finish, we want to do our axis of symmetry. Axis of symmetry is x equals what?
2.
Not 2, but -2. You see where I got that from? This part is the same as what we just did on the last page. Now, the vertex goes in the middle of your table. Now, to finish filling in your table, you backtrack. What's 1 less than -2?
-3.
Good. And 1 less than that?
-4.
1 more than -2?
1.
And then
0.
0. So that's going to be the rest of your table that you're going to need to fill in. So the way we fill in the table on the y side is we take those x values that we just came up with and we're going to be plugging them back into the equation. So let's plug in -4, okay? So we have y equals -4 plus 2 squared plus 7. So we work inside the parentheses first. Remember PEMDAS? What is -4 plus 2? -2. Now, what comes after p in PEMDAS? P exponents. So we're going to do the exponents. So what's -2 to the second power?
-4.
Yep, that's going to become a -4 because of that negative sign on the outside.
+4.
Yep, it becomes a positive, but then it becomes negative again because see this negative out here? That makes it negative. Plus 7. What's -4 plus 7? Same thing as 7 minus 4. What's 7 minus 4? 3. So this is 3. Which means if this is 3, what other one is 3?
3.
0 is also 3, right? Because they always have that symmetry. You remember the symmetry of the quadratic? They always match here. And then what else matches? These two always match. You see that? Okay.
I don't know why everything's saying it's only 1 year and not the other.
What?
Everything is saying it's only 1 year and not the other.
Well, you gotta focus.
I am.
All right, so what's the next one we're gonna plug in for x?
4.
What's the next part in the table? We just did -4. What's next in the table?
-3.
-3. So we're gonna take y equals negative 3 plus 2 squared plus 7. What is negative 3 plus 2?
Negative 1.
Very good, negative 1. What is negative 1 squared?
Negative 1.
Not negative 1,
Positive 1.
positive 1, but then it becomes negative again because of that negative sign on the outside.
I said negative 1 first time.
You did, but I just want to make sure you understand why it's negative. So, what is 7 minus 1?
6.
Good. So this is 6, which means this is also 6. See how that pattern of symmetry that the quadratics have?
I know it is, right?
Now, we're going to plot these points. Negative 2, 1, 2, 3, 4, 5, 6, 7. Negative 3, 6. Negative 2, 6. 0, 3, 1, 2, 3.
Negative 2.
Oh, I was just counting it in my head. And then this one. So you're just plotting those points however you do it. Connect them, and if you don't end up with a shape that looks like this, you know you went wrong somewhere along the line, okay?
Oh my god, now I gotta cry. Miss, why do we gotta do all that work?
I think you're like proficient in complaining. That's all I
So
know.
much brain power to put a dot on. I swear it just consumes me more every time I have to press it on.
Okay, I'm sorry to hear that. We know. Okay. Is this a maximum or a minimum?
Maximum.
It is a maximum. Does everybody see why it's a maximum? Because it's the highest point. Good.
I can't believe you got that wrong, Sean.
Shut up.
So, does anyone have any questions about this question?
Question.
Yes.
Alright.
Oh. I thought you were going to ask something. I know.
It's not even funny.
I know it's not funny, that's why I'm so confused, but you know what? If it makes you laugh, I'm happy to go with it. Are we ready to move on to number 6, the last example?
No.
Not yet?
It
Alright.
kind of looks like a house.
Sort of, yeah.
Can I transfer myself?
You're welcome to try it by yourself. We're going to go over it, but if you want to like take a second and try it on your own, that's fine.
Alright, Miss, you can go on.
I can move
But
on.
there's no maximum, no.
Alright, let's do the next one. So, first thing we got to do is what we did on the last, the first 2 pages. We have to identify our vertex. So, what's my h value here?
Negative 1, 0.
Wait, what is it?
Negative 1, 0.
Which happens to your h value?
That's 1.
It's reverted.
Yep, it flips signs, and there is no k, so it's 0. Now, your axis symmetry is always x equals whatever your x coordinate of your vertex is. We can't find out max and min until we graph it.
There's nothing wrong with
There is a way, I know, me too. So this is going to be 1, 0, that's the middle of your table, okay? What's 1 less than 1?
0.
1 less than 0?
Negative 1.
Good, and the other way is going to be?
1, 2, 3.
Yep, 1, 2, 3. Good. So, we have to plug these values in to actually solve this, right? So, I'm going to take my equation, and I'm going to plug negative 1 into it, because I need to find this value. So I'm going to plug in negative 1. So all I did was I took the x and replaced it with negative 1. What is negative 1 minus 1?
0.
That would be negative 1 plus 1. So, if you're in debt $1, and you decide to borrow another $1 from that person, how much debt are you in now? Yes, negative 2.
I don't know why negative 1 and a negative 1 next to each other is so weird.
Sorry.
It's one of those randomest things. No one cares.
I care.
What is negative 2 to the second power?
Negative 4.
Positive 4.
Wait, repeat.
Anytime you square anything ever in your whole entire life, it will always become.
On our paper, it's 2. Instead of the 3, it's 2.
Oh, you guys don't have the same question?
No, it's the same thing except for the 3 is 2.
Oh, this
Right.
3 right here?
Just turn it
Yeah.
into a 3.
There we go. We'll turn it into a 2 for you guys. I'll match
Oh,
your
just
your
turn it
notes.
into a 3 because we already did all that work.
We didn't do any of that work yet. I don't know what you're talking about. Tristan, it's okay. Okay. So, we're going to switch it to a 2. So it matches your paper, okay? It's going to be easier that way. What is negative 2 to the second power? We just
Positive 4.
positive 4. What's positive 4 times 2?
8.
8. This is 8.
Hang on, now I gotta
Wow, how will you survive with the pencil, with the eraser I gave you that you have to use? Okay, so what's the next number that we're going to plug into our equation?
0.
Good, we're going to plug 0 in. And it actually is a good thing we switched it to a 2 because it's not going to go off the graph now. What is 0 minus 1?
0.
If you have no money and I take $1 away from you,
Zero.
what, negative 1. What's and if you don't know, you guys can use a calculator. What's negative 1 squared?
Negative 1.
Anytime you square anything, it will always be
Positive.
positive.
You know what
1.
you're talking.
What's 2 times 1?
2.
2. Now, do we have to finish the plugging in for the rest of my table? No, what's this value going to be?
8.
2.
2, and this one's going to be
8.
8. Are you starting to see the pattern situation?
Yes.
Okay, now we're going to plot them. Plot negative 1, 8. So negative 1, 1, 2, 3, 4, 5, 6, 7, 8.
Very top.
Very top, good. 0, 2, 1, 0, 2, 2, and 3, 8.
Oh my god, I have a child of mine. It's so crazy.
We plot it. And is this point the vertex? This is your vertex, right? Is it a maximum or a minimum?
Minimum.
Minimum. Now, does anyone know another way to tell without looking at the graph?
Yeah, just look at if the vertex is less.
That's one way, but there's actually an easier way. So the value in the front, the A value, if it's positive, it will be a minimum. If it's negative, it will be a maximum. Okay? So that also indicates if it's frowning or smiling. This one's smiling because this is a positive number. So that is all I have for you.